Hello guys, in this video we are going to discuss types of sets. Right? So we are starting with the first type, that is empty set. So empty set is a set is said to be empty set if it does not have any element. It is denoted by this phi or this curly bracket. Okay. Null, it is also called as what? Null set or void set. So you have to understand that empty set is a set which does not have any element in that. So we will take one example. Fine. Can we write the set of all odd natural numbers divisible by 2? It is an empty set, right? So odd natural numbers cannot be divisible, are not divisible by 2, right? So we'll take one more example. We'll write our set is equal to a set x such that x belongs to n. This means belongs to n, and x lies between 1 and 2. Fine. Here n is what? Natural number. So x belongs to n and x should lie between 1 and 2. So there is no natural number which lies between what? 1 and 2. So this is a what? Null set or empty set. Fine. So this is nothing but in the roster form. So empty set can be written in roster form, that is in this way, this symbol. Only the curly brackets, two curly brackets. Fine. So moving on to the next, that is singleton set. So a set which contains only one element is called singleton. You can remember single, right? So only it should contain only one element. So we can write, suppose for example, suppose S is a set. Fine. S is equal to x such that x belongs to n and x square equal to 9. Fine. X square equal to what? 9. So x is a natural number and x square equal to 9. That means what will be the x value? That will be 3, only 3, right? So we can write, so this is what a singleton. It only contains one element. So we can take many other examples. Okay. Now moving on to the third set, that is equal sets. Equal sets means two sets are said to be equal if they have same elements. Okay, if they have same elements. So two sets you have to compare. Suppose I have taken here a equal to 2, 4, 6, 8. Fine. 2, 4, 6, 8. And I'll take one more, that is b equal to b set, that is x such that x is an even natural number. Fine. Which is less than 10. So this is also a set. Fine. So you have to compare these two sets. So when you see these two sets, this is what a is nothing but 2, 4, 6, 8, and b is x such that x is an even natural number less than 10. So you have to compare and tell that whether these are equal or not. We can say these are equal because b can be written in roster form, right? Tabular form. So when you write this in tabular form, you will get this one only, this set. Okay. So when you write x is such that x is an even natural number, so this is also even natural number which is less than 10. So 2, 4, 6, 8 are less than 10. So this is nothing but, so b is nothing but equal to a, we can say. So a equal to b. Okay. Moving on to the fourth one, that is finite set. So finite set, a set which contains finite number of elements is called finite set. So if you take, means which the elements are countable, we can say. Fine. If you take an example, x such that x belongs to n and x is less than or equal to 10. Fine. X is a natural number which belongs to what? X is a natural number which belongs to n. Fine. And x is less than or equal to what? 10. So this is the limit. So you can count, right? So if you write the set tree, it will be 1 2 3 4 5 6 so on till 10, right? So you can count 1 2 3 like that. So it is countable, the elements are countable, so we can say that this is finite set. So there will be a limit, fine, so that this set becomes a countable set, or we can count the number of elements. So moving on to the next set, that is infinite set. So in this, basically you cannot count. So a set which is not finite or which contains infinite number of elements is called an infinite set. If I write a set of what? Natural numbers, it is infinite set of whole numbers, rational numbers. Or I can write the set of points on a line. Set of points on a line, it is infinite, fine. So we can say that lines have what? Infinite points on it. So basically we can say that infinite set means which is not countable, so it contains infinite number of elements. Moving on to the last and final set, we can say equivalent sets. So here also you have to take two sets, so you have to compare that. In the equal sets also we have compared two sets. Now the two sets A and B are said to be equivalent if number of A equal to number of B. What is mean by when number of elements in A will be equal to number of elements in B. Suppose I will take A as a set 2, 3, 5, and B I will take something around 6, 7, 8, something, fine. So when you observe here, number of elements in A are 1 2 3, so 3. Number of elements in B are again 1 2 3. So we can say set A as well as B contains equal number of elements, so we can say these two sets are what? Equivalent sets. So fine.